ProSPA is really one of the stepping stones between the early robotic phase that we're seeing now and the future where human activity on the lunar surface may make use of lunar resources in order to have a sustainable presence on the lunar surface.
If you land anywhere on the moon, you can extract oxygen. If you land at the poles, it may be a little easier because you can get to water and other volatiles that might be there. And so volatiles are things that can be very mobile, so they can sublime into a vacuum. But obviously they're of interest to us because we can breathe and drink them. So water ice, for example, is thought to be abundant at the lunar polar regions.
So ProSPA is a combination of a drilling and sample analysis package. The drill will drill down to depths of up to 1 meter below the surface. So it's not the first time that drilling has been employed on the moon, but it's the first time that it will have been done in these polar regions.
We are now going to test the first model that has been built. We are going to test it, so to see if the drill works, all the instruments and mechanism works perfectly. And we are going to perform some drilling tests and sampling coring and sample delivery to the sampling system.
We collect 2 samples while after drilling. One sample is collected using a dedicated mechanism that allows to collect the sample and close the chamber after the collection. So we keep the sample within a dedicated chamber for the Russian sample. And then we perform the same operation with the for the European instruments.
We don't know exactly how much water ice we might find. So in the tests, we're doing some that are dry, which have no water ice in. For others, we inject a little bit of water, and then we range up to saturated regolith, which has a very high fraction of water in the subsurface.
One of the tests on which I am more curious of is the test with the 6% of water content. So we will weight the percentage of the water, we will mix like an ice cream making, and then we will freeze the simulant down to the minus 150 degrees C.
Under lunar vacuum, when you have an icy material, as soon as you expose it to higher temperatures, it immediately sublimates into the vacuum. So it doesn't go through a melting point, it just disappears into a gaseous form and you've lost your sample.
The point is, during the drilling, you are producing heat due to the mechanical attrition of the drill tip and the lunar soil. This is unavoidable. So what we are doing is to balance the power injected, controlling the rotation of the coring and the rotation and the speed of the drill in order not to go too fast and so not to produce too much heat.
The ProSPA is the European instrument that is part of ProSPA. It will be based on miniaturized oven which will receive the samples from the drill. It will seal the ovens and it will perform the measurement of the contents. ProSPA contains a small carousel and with a disc on which 25 ovens are mounted. We started many years ago in studying coring and drilling systems. The first drill that went to space was the Rosetta drill for the Rosetta mission.
ProSPA has a great heritage from Rosetta, from the conceptual point of view, because there is the task of drill, there is the task of collect the sample and to deliver the sample to the instrument, and the in situ observation of the material.
Our objective is not just to fly the single ProSPA payload, but also to put Europe in a position where we can also work on the topic of lunar resources in the context of other payloads, and really to develop the expertise of the community in this area, which is already happening today.
From an exploration point of view, it has the potential to change the moon from a thing that we see in the sky to a place that we can go. By understanding how we can use the resources that are there, it then opens the door for other people to potentially exploit those resources.
We really hope to go to the moon very soon, and few years from now, so this is really exciting and it has just begun.
My hope is that with missions like Prospect and the missions we're seeing coming up, that this is actually opening a new door to lunar exploration, which might actually see a bigger participation of the public, and perhaps even see my children or grandchildren participating in that exploration and visiting or even living or working on the lunar surface.